Welcome to Across the Globe. Today we will learn about generators in Python. Generators in Python are functions that produce a sequence of values incrementally. Unlike lists, generators do not store all values in memory simultaneously, enhancing memory efficiency. Therefore, when handling substantial datasets where memory preservation is critical, generators serve as a more viable option. For instance, when processing extensive log files or streaming data from a live source, generators are beneficial due to their ability to manage data incrementally without overwhelming memory resources. Generators are formed by employing the yield keyword within a function. Upon calling a generator function, it produces a generator object without running the function's code. Each iteration over the generator object prompts the function to resume execution from the previous stopping point. For instance, consider a scenario where a generator is used to generate Fibonacci numbers. Whenever the generator is iterated over, it calculates the subsequent Fibonacci number without recalculating previous values. Thus, generators efficiently manage memory by producing values dynamically when needed. The given code snippet defines a generator function called countdown, which yields numbers starting from the input value descending to 1. The countdown function takes a single argument n, representing the starting number. Within a while loop, it yields the current value of n and decrements n by 1 in each iteration. To use this generator, a for loop iterates over the countdown generator, initialized with an argument of 5. During each iteration, the current value generated by the countdown function is printed. For example, if the generator is initiated with 5 as the starting number, the output of the loop will be 5, 4, 3, 2, 1. Generators in Python are memory-efficient data structures that do not store all values simultaneously. They are valuable when handling sizable datasets or an undetermined number of items. Generators are conveniently crafted using comprehension syntax, which enhances code conciseness. For instance, when parsing an extensive log file line by line or calculating Fibonacci numbers without predetermined endpoint, generators prove instrumental due to their ability to generate values on demand while conserving memory resources efficiently. Generator functions utilize the yield keyword to provide values incrementally, preserving their state between calls. This feature enables them to generate a sequence of values gradually. Conversely, regular functions employ return to return a solitary output and execute completely upon each call. As a result, generator functions exhibit a distinct behavior by yielding values step by step, whereas regular functions return a final result in entirety every time they are invoked. An illustrative example would be a generator function that yields the next value in a Fibonacci sequence with each call, maintaining its internal state to produce subsequent numbers compared to a regular function that computes and returns a single Fibonacci value upon each invocation. Using a generator in Python is like ordering a dish that is made fresh to order at a restaurant. Just like a chef creates the dish step by step as it is being ordered, a generator in Python produces values one at a time when needed. This is similar to how a generator function in Python yields values one by one as they are requested by the program. By only processing and returning values as needed, generators save memory and improve efficiency in Python programs. Hey, Code Conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. Generators in Python are a powerful tool for creating iterators. In this code snippet, we define a generator function called example generator. This generator function uses the yield keyword to produce values one by one. When the function is called, it returns a generator object without actually running the function. We create an instance of the generator using gen equals example generator. By calling nextGen, we can retrieve the next value from the generator. The first 3 calls to nextGen will output this, is, and an, respectively. Once the first 3 values are printed, we enter a for loop to iterate through the remaining values in the generator. This loop continues where we left off, printing example and generator in sequence. Generators are efficient because they generate values on the fly, only creating values when requested. They excel in scenarios where large amounts of data need to be processed one element at a time, conserving memory and optimizing performance. One real-world example of using generators is processing large files line by line. Instead of loading the entire file into memory, you can create a generator that yields one line at a time, avoiding memory issues with large files. Generators in Python are commonly used in various industrial applications to efficiently handle large datasets or streams of data. One prominent example is in web scraping, where generators can be employed to process and extract information from web pages one element at a time. By generating values on the fly, memory consumption is minimized, enabling the scraping of massive websites without overwhelming the system resources. Another practical application of generators is in data processing pipelines, particularly in scenarios involving real-time data streams. Generators can be utilized to transform, filter, or aggregate data as it flows through the pipeline, allowing for continuous processing without the need to store all intermediate results in memory. This approach is crucial in systems where data arrival rates are high and processing speed is a critical factor. In conclusion, generators in Python play a vital role in optimizing resource usage and streamlining data processing workflows across various industries and domains. Keep learning, stay curious, and I'll catch you in the next video.